Okay, now today let's move on to solve the challenge problem of the chapter 17, an analytical geometry. Yeah, so we analyzed the geometry problem using the put them into the coordinates to converting the problem into the algebra. But I want to say, okay, first is try to use as much as possible of the geometry. Use geometry as much as possible, okay, to reduce the calculation, okay. Okay, this is very important. It's still geometry. Don't try to solve it like algebra. Okay, now let's starting with the first one. So we want to find the equation whose graph is a circle, okay, and passing through the origin and both the x-intercept and y-intercept of this graph. So y equals 0, so x-intercept is 18, and x equals 0, then y-intercept is negative 6. So we parsing the a, b, and the origin c, and want to see what is the what is the circle function here, right? To define a circle, okay, we need the center and the radius, right? So here we learned that, this is the 90 degrees. So that's why if there is a circle here, that means AB is the radius, AB is the diameter, right? So the midpoint M will be the center, right? So M is equal to half of the A plus half of the B, then is equal to half of the then the 0, negative 6 plus the 18 and 0, right? So it's 9 and negative 3. So we know we already know the center, right? Now the second part is the radius, right? So the radius will equal to AM or equal to BM equal to half of the AB. So now let's solve the AB, okay? So AB per Pythagorean theorem will be the 6 square plus the 18 square. Uh, so uh, uh, okay, and divided by 2, then the radius will be the 6 square plus 18 square, then divided by 4, it's equal to the square root of 90. So we know the center and we know the radius, right? So the circle is x minus 9 square plus the y plus 3 square is equal to the 90, okay. Next, so the graph of the equation is rotated 90 degrees clockwise by the origin. So let's solve the A first, okay? So the A is first y equals 3x, means passing the origin. So 1, 2, 3. So this is the y equals 3x. Okay, so if you're rotating 90 degree clockwise, rotating something the degree like this, right? So it's rotating also about the origin, okay? About the origin. Now we produce this is the k, right? So you can see the slope is 3, right? So the slope of this one is negative 1, 3, right? So it's y equal negative 1 1/3 x. Okay. For the problem B, okay. So we have the original one is so x equals 0, y equals negative 6, and y equals 0, x equals 2. So we want to rotating this line, right? We want to rotating this line through by the origin, right? By 90 degrees with clockwise. Okay, so you can see this point is A, right? This point is B. A is rotating to the A prime, and the B is getting rotating to the B prime. Okay, so the A prime will be 0 and -2, and the B prime will be -6 and 0. So now this is the line, right? So now you can we know this k is 3, so this k is -1/3, right? And then you can write this. It also passing the point of the 0 and -2, so it's y equals -1/3 of the x minus 2. Next, so we have a graph. We graph two circles. Okay, these are two circles, and these two circles can intersect when the k is between A and B. Okay, and what is the A and B? So let's rewrite this equation. Okay, so x squared in the standard format. Okay, x squared minus 12x plus y squared minus 6y equals 4. Then we need to make it a perfect square, like the x minus 6 bracket square plus the y minus 3 bracket square is equal to 4 plus the 36 plus 9. Then this one is equal to the 49. Okay, this is the first equation, and the second equation is this. So it is the x squared minus 4x plus the y squared minus 12y is equal to k. Then we can write into the x minus 2 bracket square plus the y minus 6. The bracket square is equal to the k plus the 36 plus 4 is k plus 40. Okay, now let's draw this the center on the picture. Okay, so x, y, and 0. Then we know it's 6. The first 6 is 6, 3, right? So this is 3. This is 6. This is about 3. So the first center is 01 is the 6 and the 3, and with the radius of 7, right? So this is the radius of the 7. So this is the radius. Okay, and the O2 is the O2 is 2 and 6. So we have this 2 and 6. Right, it's 2 and 6 is O2. Then we connected the O1 and O2, right? So what you can see, in order to have the O2 and O1 have a common point, right? Intersect point. So the radius of the O2 must be at least this. Let me change another color. So the radius of O2 must be at least this one, right? So it's the 7 minus the O1 O2, right? And the radius, because it's on the other side, is this is the 7, right? So the radius of the O2 in maximum should be 7 plus O1 O2, right? So now the problem becomes to calculate the O1 O2. That's very simple, right? That is 6 minus 3 is 3 square plus 2 minus 6 negative 4 square. So that's why this is a 5. So O1 O2 is 5. So we know the k should be at least greater than the 7 minus 5, and also let's all equal than. Oh no, not the k. Okay, so the radius of the R2. Okay, the radius of the 2 should be less than or equal and greater or equal than the 5 plus 7. So the R2 should be be within the 2 and also the 12. Okay, so we know the R2, and the k plus 40 is the R2 square, right? So this one should be less than 2 square and the 12 square. So that's why the k should be greater or equal than the negative 36 or less or equal than the 104, right? So the question is asking us what is a b minus a, right? So this is the b, this is the a. So b minus a equal to the 104 plus the 36 is 140. So how many points? Okay, this one I may take some time to extend this problem a little bit. Okay, not only the problem by itself. So how many points are equal distance to the x-axis and y-axis and to the x plus y equals 2. Okay, so you can see the x-axis here is 2, here is 2, 0, 2, and 2, 0. Okay, so this is the ABC. So this is the triangle ABC, right? So what kind of the point can have equal distance to the AC, BC, and AB? Okay, so if you know, you're familiar with the incenter and the excenter. Okay, so there are 4 points. They are I, IA, IB, IC. Okay, so let's see what's the incenter. The incenter is the angle bisector of the intersection of the angle bisector, right? So the I here must on the y equals x, right? And this is the 45 degrees. Okay. And also, I mean, the angle bisector, we can also calculate the tangent of this, right? The tangent of this one is not simple because it's not easy. I mean, I'm sorry, it's not difficult. Because, I mean, we can basically use the angle bisector theorem, okay? The angle bisector theorem tells us, for example, this is D, right? We know the CD over the DB will be equal the AC over the AB, right? So this AB is 2 root 2, so it equal to 2 over 2 root 2 is 1 over root 2, right? So now you can see the total cut into the 1 plus root 2, right? So the one part is the 1 over 1 plus root 2 times 2, right? This is the root 2 and the root 2 plus 1. So we cut it into 2 pieces. Now, if you know it's passing the AD, right? So now you can, because you know the coordinates of the D, right, is the 2 over root 2 plus 1 over 0, okay? So now you can calculate the line of the AD, right? You can do the line of the AD, and now you see, you also know the y equals x, right? So you can try to solve the coordinates of the I. Okay. So the other thing is the talk about the x center, right? So the x center will be, we have 3 x center, okay? So here is the 45, 45, 45 is 2 and 0, and it's 0, 2. So it is ABC, right? So the x center is the angle bisector of the C here. This is called IC. Okay, and we do the angle bisector of this angle. That's the exterior angle of angle A. Angle bisector of the angle A, and here is the angle bisector of the exterior angle of the angle B. Okay, then this will be the IC. Okay, I think we already proved it before, right? They are together. So, and also if you are you know this one, so this is the C over 2. Then this is the A, right? So this angle will be 90. 180 minus A, 90 minus the A over 2, right? So C over 2, 90 plus A, 90 plus A over 2, right? So that's why this angle is B over 2. At the same time, you can do this one is 90 minus the B over 2. So this angle will be the C over 2, okay? So you can see all this info. This is the IC, right? and we also can draw the IB. Let me tell you how to calculate this IC. Okay, so the first line, I give you two lines, you can do it, right? So the first line is still y equals x. That's the first line. Okay, the second line, let's see how we can calculate the IC. Okay, so the second line will be the let's see the point is C and C, right? So because we know we know this one. Okay, so we know the we know the we know the line function of this one. Okay, so now let's see the angle bisector of B. Okay. Now we can solve it. Okay, so this angle, right? This angle is 45. So this angle is 135 over 2, right? It's half of the 135 over 2. Now we want to, once we solve the tangent 135 over 2, right? We can solve this. We can solve the line L. Okay, so the line L will be the y minus 0 is equal to the tangent 135 over 2, then x minus 2, right? So that's how to solve the half of the 135 minus 2. Okay, so this one will be we are going to using the double angle of the tangent. Okay, so the tangent 2 alpha is 2 times tangent alpha minus 1 minus tangent square alpha. Okay, so now the tangent of the 135 is -1, right? Okay, 2 alpha is equal to 135, right? So there you can solve this quadratic equation. Okay, and the tangent alpha will be greater than 0. Then and also greater than 1 because it's greater than the 45 degrees. Then you can solve, once you solve the tangent alpha, then you solve this equation, then you can solve the coordinates. Okay, so the other one is we see the IC, right? So there is also another one called the IA. The IA will be the angle bisector of this point and the exterior angle and the angle bisector of this one. Okay, so this one will be the ABC, and this will be the IA. Okay, from IA also you have the same distance. So that's why there are total of the 4 points. Okay, but you also better to be able to solve all the coordinates. Next, so we want to prove the point x is on the diameter of the PQ of a circle. Okay, so now we know the PQ is the diameter of the circle. Okay, then we have a circle with the diameter of the PQ, and the x is on the diameter, and then if AB is a chord of the circle perpendicular to PQ, then let's see if AB is this, right? So we want to prove the XA square plus the XB square equal to the XP square plus the XQ square. Okay, so now let's do the, so we can use the trigonometry to solve this problem. Okay, and also we can use the coordinates. Okay, let's see the trigonometry method first. Okay, let's see the trig method first. Okay, so for the trigonometry, we know the xa is this, right? We know the xa of the square is equal to the let's see this is the O, right? So let's see, this is the OX is P, okay? So XP will be equal to the R minus P, and XQ will equal to the X plus P, right? So the XA square will be the XP square plus the PA square, then the uh no, XP square will be the, okay, I'm sorry, this triangle. Okay, so XA square will be equal to the P square plus the R square minus 2PR, then cosine of alpha. This angle is alpha, right? And now let's solve the XB square. XB square will equal to the P square plus the R square minus 2PR, right? Then the cosine is, so if this is the symmetry, right? Because these are parallel, okay? So that's why this angle is also alpha, right? So this angle will be 180 minus alpha. Okay, so this will equal to P square plus R square plus 2PR, then the cosine alpha. Then you add them together will be the XA square plus the XB square is equal to the is the 2P square plus the 2R square. Okay, so then let's see what is the xp square plus the xq square, right? The xp square is r minus p bracket square plus the r minus r plus p bracket square. Then it is also to the 2p square plus the 2r square, right? So here is the two results. Now you can see they are equal, so that's why you can prove this equal. Okay, this is the trig method. Okay, there is another one is the analytic. Okay, it's Coord-Bash method. Coord-Bash. Okay, so to do the Coord-Bash, let's put some coordinates here. Okay, so here is the PQ. Let's see the radius of the R and the 0 and the 0 and the negative R and the 0, right? And let's see the point X is located at X and 0. Then the point A and B, because they are parallel, right? They are parallel, so let's see, this is the negative A and M. This is the A and M, right? So because X, A, and B are on the circle, right? So we know the A square plus M square is equal to R square. Okay, so now let's calculating what is the X P square plus XQ square is equal to the P plus R bracket square plus the P minus R bracket square is 2P square plus 2R square. Okay, now let's calculating the XA square is equal to the X plus A bracket square plus the M square. Then XB square is equal to the X minus A bracket square plus the M square. So it's equal to the X square plus the A square plus M square plus 2AX. This one is equals to the oh, I'm sorry, this is X. Okay, I changed the variable. So X. Then this one will be the X square plus the a square minus plus the m square minus 2ax. Then if we add them together, then it is become the 2x square plus the 2a square plus m square, right? Because a square and m square satisfy the circle function, right? To put inside here, so it's 2x squared plus the 2r squared. Okay, so it's still the same thing, 2x squared, 2r squared, 2x squared, 2r squared. So they are equal. Okay. Next. So this one is called, we are using the method called the coordinating referencing. Okay, of the translation, we change the center of the coordinates. Okay. So let me give you a simple example here. Okay, so if the origin, right, we circle, we reference around the origin. Okay, so if we have the a, we know it's a0, we know this point is ab, right? So it's a and b. So after these coordinates, okay, if it is clockwise 90 degrees, okay, if it is clockwise 90 degrees, okay, so this coordinates, okay, will be the negative a, okay, and you can see it's still b. Okay, because you can from here you can see if a b are positive, right? So here x is still positive, but it's put the b here. Okay, put the b here and put the a here, because a it become negative. Okay, here, so that's why you put negative a. Okay, so that means the point rotating, if you know its coordinates, but if you do clockwise or counterclockwise through the origins, it's easy to solve. Okay, so if we do the counterclockwise, right, you can see now the x will be negative, right? So b will be negative, and the y is still positive, right? So y still keeps the a. Okay, now let's do it. Okay, so I mean, this one I will make it like the first question will be more difficult. I mean, more like the processing seems to be don't need to be that complicated. Okay, but I want to show this method, so that's why let's do it. Okay, so we have a coordinate system, and we have the point u is negative 4, 3. Okay, 1, 2, 3, 4. 1, 1, 2, 3. Okay, so we have the u is negative 4 and 3, and we have the v is 2 and 1. Okay, so v is 2 and 1. Okay, so we have the a is the negative 1 and 3. Okay, so a is negative 1 and 3, right? Okay, so now let's see. Okay, so we do the a is rotating the clockwise about the u, right? A is rotating, you can see a is rotating to here, very simple, right? But let's do it in the change the coordinates. Okay, so here is the center of the o, and we convert into center of the u. Okay, now let's see. Okay, so the a is the point A is negative 1 and 3, right? Because we want to circle around the u, so we better to use the u as the 0, 0, right? To get a better u 0, 0 means we have to add the x coordinates to plus 4, then it becomes 0. So negative, it becomes the negative plus 4 is 3, right? And this one, to make it 0 for the y, we need to subtract 3, right? So that's why it becomes 0. Okay, so then once we center around u, right? So once we set our the coordinate center to here, right? Now we know the 90 degrees, right? 90 degree just means we need to make its y become the x become the y, right? So the x becomes the y, right? And the y becomes the negative x, okay? So it becomes negative x. Okay, now we converting this point back to the center of the O, right? To get the center of the O, so this one need to be subtracted by 4, right? So negative 4. And to convert into the center of the O, then need to be plus by 3, right? So plus by 3. Now you can see this is A prime in the coordinates of in the center of the O. Okay, this is the center of the U. Okay, now you understand the basic concepts of this. Okay, now we are going to deal with A prime. Okay, so the A prime now we is a clockwise around the V, right? So we need to the center of the V. Let's converting to the 4 to the center of the V. Okay, so 2, right? So we need to subtract 2, then it becomes the negative 6, and subtract 1, it becomes negative 1, right? Okay, now we can think. Okay, so if it's the surrounding it's center of this, and when we do this right here, so AB, right? You can simply think as positive. It doesn't matter. Okay, the results will keep the same. So it will be the x become the still positive. So it will be x will be the B, right? And the y is negative A, right? Okay, so now let's see. So we need to keep the B and the negative A. Okay, so now let's converting back to the original ones, right? Since we subtract 2, now we need to add 2, right? Is 1. We subtract 1, we need to add 1, right? That's 7. We subtract 2. Oh, I'm sorry, I get that wrong. So V is 2 negative 1. Yeah. Okay, let's fix it. V is 2 negative 1. Okay, so 2 negative 1. If it's 2 negative 1, then we need to add 1, then this with the plus 1, then it will keep the plus 1 and the plus 6. Then this plus 1, and we take out 2 is the negative 1, and this is the 6, right? Minus 1 is 5. Sorry, 1 plus 2 is 3. Right, since we take out the 2, right, and this one should become the relative small, so we need to add 2 to converting to its 3. Okay, so it's converting back. Now we have the A prime prime. Okay, so this is this process. Okay, now let's converting another point of the B. This is the A. So you know this process, then we can do the B easily. Okay. Now, if the U is equal, U is what? U is negative 4, 3, and the V is 2, negative 1. Then what's the B? The B is 7, negative 2. The B is 7, negative 2. So let's convert into here, right? So it becomes the 11, right? Plus 4 and minus 3 is negative 5. Then we know we need to keep the negative 5 and negative 11, right? And then we convert it back. Okay, when converting back is 0, is need to be take out 4. Yeah, we need to take out 4 is -9, and 3 we need to add 3 is -8. Then we converting reference to this, right? So take out 2 is -11, then -7. Now we converting back to the -7 and 11. Now we convert back to the 2. So we subtract 2 before. Now we need to add 2 is -5, and we plus 1 we need to subtract 1 and 10. Okay, so this is the B prime prime, this is the B, and A prime prime and A, right? Okay, so the question is asking C is find the midpoint of AA and A prime prime. So the midpoint of A prime prime will be half of the A plus half of the A prime prime will equal to half of the, it's the -1, 3 plus the 3 and 5. So that's why this is the -1 and 4. Okay, let's see the endpoint of a B prime prime is a half of the B plus half of the B prime prime is half of the 7 -2 plus the -5 and 10. So it's also the 1 and the -4. Okay, so they are the same. Okay, now why this is the case? So that's why the problem C is D. This is the C. Okay, so this part is the C. So this part is C. This part is C. What happened with this? Okay. This part is the C. Okay. Now the final part is the D. Is we want to do the same thing again. Okay. So what is the U is -4, 3, and the V is 2, -1. Okay, let's do any arbitrary point. Okay, let's say the point is AB. Then we converting here is A plus 4 and B minus 3. Then we converting here is the B minus 3, then -8 times minus -4. Then we converting here is the B minus 7, then the -A plus 1. Then we converting to here -2, right? Is B minus 9, and plus 1 -A plus 2. Then we converting to here is the -A plus 2, then 9 minus B. Then we converting back, so it makes the small than it should be big, so it's the -A plus 4 and 8 minus B. Okay, so this is any arbitrary point A, and this is the A prime prime, right? Now let's see the midpoint is half of A plus half of the A prime prime, so it's half of the AB and plus the -A plus 4 and 8 minus B, so it's half of the 4 and Oh, I'm sorry. Let me see. B minus 7, negative A. Oh, here, negative 1. Okay, so that's why this one is plus 1 is negative A. Then this one is A plus 2. Okay, I'm sorry for this calculation. So that's 2. Okay, so this is the concept how we can change the reference and do this. So no matter what rotating about which coordinates, you just use this method and be careful of your calculation. Okay. For this one, so it's we have a square, right? And we pick any point on P on this on the DC, and then we can do erected another square of the APYZ and another square of the BPWX. So the final one is let us to prove the O2O01P is a parallelogram. So to prove the parallelogram, something you can think is if you can prove O to O parallel to O1P, right? And O to O equals to O1P, that's a parallelogram. Okay, you can also prove the O to O parallel to O1P and the O to P parallel to the O01. Okay, something like that. So let's put them into the coordinate system. Okay, let me set up the coordinate system using the first is the ABCD. Let's set up as a P. Okay, so let me set up, because I mean this one is, it doesn't matter of the side length, right? So we can make it simple to see this the P is 0, 0, and this one, for example, is the this one is the A and the 0, so this one is the negative is the negative A, negative 1 plus A and 0. Okay, then B will be the A and 1, and the A will be the negative A, but negative 1 plus A and 1. Okay, then P will be this. So let's see the erected. The erected means this one will be the square, right? So if you connected this one, right? So this is O1. So you can see there is a this one is the 45 45 90. It's an isosceles right triangle, right? The O is the center, right? So now you know the center of the O, right? So the radius will be equal to the O1P, right? And also, so now you can see this one. So we know if AP is T, right? So then this one is the T over root 2, right? And here is the A, here is the B, right? Now, if we know the A's coordinates, then we're rotating this one by 90 degrees, right? Now you can see the Y is positive getting to the negative, right? So that's why the X is negative. So that's why it becomes this, and the X originally is negative, all right? Now is still the x becomes a y, right? But the x is negative, so that's -1 of this. So this is the point of the, what's this point? Y. Okay, so the same thing. Let's see this. Okay. So now we need to calculating the point of the w, right? The point of the w. So the point w is this one getting rotated 90 degrees clockwise, right? So you can see the x is positive, getting to the y become negative, right? So x positive. Now y is positive, getting to the x is negative, right? Getting to the x is positive, so keep the positive. Okay, so now we solve this one, right? But you can see the O1 is the midpoint of the a and the y, right? So now we can solve the O1 is half of the a plus half of the y, so it's equal to half of the what's the a? -1 plus a and the 1, okay, plus the y is the -1 and the -1 plus a. Okay, so the O1's coordinates is half of the -2 plus a, and this one is half of the a. Now we solve the O1 coordinates, right? And now let's solve the O2 coordinates. Okay. Oh, here is the coordinates of the O is simple, right? Coordinates O is half for the y, right? And this one is half of the D and the C, right? So it's -1 plus 2a. Okay. Now we can solve the O2 coordinates is half of the B plus the half of the W. Then will be equal to half of the B and half of the W. Then will equal to the A and 1 plus the W is the 1 and -a. So this one will become the half of the a plus 1 and the half of the 1 minus a. Okay, so we already know all these coordinates, right? And the p is 0, 0, right? So now you can calculating the slope of the k O1p. And also you can calculating the slope of the k O2. Let me see. I'm sorry. Here is the O2. Then you can also calculating the slope of the OO2. Okay. Once you calculating all the slopes, you will see this is a parallelogram. Yeah. Next. So we want to find the largest value of the y over x. The y over x is a tangent, right? So you have a point. For any, you have a real point, right? So this is the y over x is the tangent of the theta, which is the slope of the line, right? So let's see what's this problem. Okay, so we have a circle here. Is 3 and 3, right? So this is the center 3, 3, and the 3, 3 root 6, right? So 3 is root 9, so root 6 is less than that. So now you can see we have a circle. The circle did not touch the x and y axis, right? So we want to see what's the smallest tangent theta and what's the biggest one. Okay, so you can see the smallest tangent is here and the largest tangent is here, right? So we can see that t AB are the tangent point. So we know when we connected it, it will be 90 degrees. And if we connected it to this, right? Let's see, this is C, this is O. So we know that OB will be equals to OA, right? Is the power of the point. Okay, from one point to the tangent to the circle, they are all the same, right? Then we also can prove the OBC will be congruent to the OAC. Okay, then this triangle means this is the angle bisector. Okay, this is the angle bisector, right? So now we can see, okay, so we can see this one is the root 6, okay, and the tangent, and this one is the 3, and the 3 will be the 3 square plus 3 square is the 18, right? So the OC is equals to 18. This is the root of 6. Okay, now we can calculating the theta, right? So the theta will be equal to, and this one is the 45 degrees, right? 45 degrees. Okay, so we can calculating the tangent theta will be equal to the root 6. Then root 18 minus 6 is root 6 over root 12 is 1 over root 2. Okay, so we can calculate the tangent theta, right? So the smallest, this alpha, the tangent alpha will be the tangent 45 minus theta, right? The other one will be the tangent, the alpha max will be the tangent 45 plus the theta, right? So based on the addition trick, this one will be the tangent 45 minus the tangent theta, right? And it will be 1 plus the tangent 45 times the tangent theta. Okay, so we know the tangent theta, right? If you get in, you will see this one is negative 2 minus 1 and square root 2 plus 1. Okay, then this one will be the 3 plus 2 root 2. Okay, so this one is the largest tangent answer. Okay, so the final one is the A1, A2, and the B1, B2 are the chord. Okay, so let's draw the circle first. Okay, so we have the A1 and A2, and the B1 and the B2 are tangent. I mean a perpendicular chord, right? So each passing through a fixed point. So P is fixed. Okay, so O is here, P is fixed. So we want to prove that A1, A2 square plus B1, B2 square is independent. Okay, so for it to be a fix, okay, let's see, we always land to the, because I mean, once we land the perpendicular, we know the M is a point, is the midpoint of the A1, A2, and the N is the midpoint of the B1, B2. Okay. Because P is fixed, right? That means this the A0 is fixed. So M square plus N square is equal to A0 square. Okay. So M square plus N square will be fixed. So let's calculating what is the AA2 square, right? So A1A2 square is equal to 2A1M square is equal to 4A1M square. So it's equal to 4 times the A1M is equal to the R square minus the M square, right? Okay, similarly, we can see the b1, b2 square is equal to 4 times the r square minus the n square. Then we need to add them together, right? So it becomes the 4r square plus the 4r square minus the 4 of the m square plus the n square. The m square plus the n square is op square, right? It's a0 square. It's a constant. So that's why this is a constant. It doesn't change. Okay, so that's it for the challenge problem of this chapter. Thank you. Bye.